Hello everyone, let's now proceed to factoring and division of polynomials. So let's define factoring first. So we have factoring refers to the process of writing a polynomial as a product. Okay, so let's have an example. Let's say you have x squared plus 6 plus x minus 6. Then the factors of that are x plus 3 and x minus 2. Okay, so you will have a We'll discuss the techniques and how to factor later, but as of now, so these are the factors of this particular polynomial. Okay, so if a polynomial cannot be written as a product of two other polynomials, then the polynomial is said to be prime. Okay, so let's say, for example, you were given x plus 2. Now, for x plus 2, you can no longer factor it, okay, in terms of two other polynomials. So this is considered to be prime. Now, in our example here, so x plus 3 and x minus 2 are both prime. You can no longer factor them. Okay, when a polynomial has been written as a product consisting of prime factors, it is said to be factored completely. Okay, so in our example, since these are already prime, then this is said to be factored completely. Factored completely. Okay, so let's now proceed to the common monomial factor, the first type. Okay, so the common monomial factor. So let's say we were given 10x minus 50y. So we're going to use the distributive property here. Okay, so let's recall the distributive property. Let's say we have the distributive property states that a times b plus c is equal to a times b plus a times c, right? Okay, so now we have, so right now, what we have in the given is in this form, right? It's in this form, right? Okay, so what we need to do is to convert it into this form, the a times b plus c. So these are its factors. Okay, so we need to determine the a, b, and c. Okay, so for this particular, what do you think is the common factor between 10x and 50y? So it's 10, right? So it's you'll see okay, so if you express this like 10 times x minus 5y. So this is exactly the same, right? Because if we distribute this, this is 10x. Then this one, then minus 50y, right? So that is how you factor the common monomial factor, okay? This is how common monomial factoring works. Okay, so let's have another example. 4x cubed minus 2x squared. Now what do you think is the common factor for x cubed minus 2x squared? So it is 2x squared, right? 2x squared. 2x squared because 2x squared will have 2x minus 1. 2x minus 1, right? So let's see. Let's start to check. We multiply this, what do we get? 4x cubed. And we multiply this minus 2x squared. Okay? So that's the answer for this particular item. Then let's proceed to this one. This next one. Okay. So what do you think is the common factor to these to this trinomial? So what do you think is common with negative 4x squared, 12x, and negative 16? Oh, it is negative 4. Negative 4, right? Okay, negative 4. You have x squared and minus 3x and then plus 4. Okay, so you can check again by multiplying. So negative 4x squared multiplying to this, you have plus 12x Then multiplying it to this, we have negative 16, right? Okay. Okay, so for the last one, for the last example, we have here, what do you think is common between this and this? It's x plus 5, right? So you can factor out x plus 5. So x plus 5 multiplied by 3x plus 2. Okay? Okay, so let's now proceed to factoring special forms. Okay, for special forms, we've already tackled these forms in multiplication of polynomials. It's just we are doing this the other way around. Instead of multiplying them, we're getting the factors. Okay, so for the difference of two squares, I write here u squared minus v squared is equal to u minus v times u plus v. Okay, so we've already encountered this in the multiplication of polynomials, right? So let's have an example for this. Let's have an example for, um, let's say we have 25 x squared minus 9y squared. Okay, 5x squared minus 9y squared. So what do you think is the u and v here? Okay, so the u and the v here is, so we have 5x minus 3y and then 5x plus 3y. Right? Because if you multiply this, let's try to perform this. Let's try to perform this. Let's try to evaluate this. That is 25x squared, and then this is plus 15xy, and then this one is negative 15xy, and then we have uh, negative 9y squared. So these two cancel out. So we are left with 25x squared minus 9y squared. Okay. So that is the difference of two squares. So mostly in these factoring problems, you need to have you need to have done a lot of exercises, because the more you do the exercises, the more you will quickly identify these forms and what their factors are. So you just need to practice a lot. So let's say we have perfect square. So we already did this in the previous lesson, right? But we did it the other way around. Okay, so let's say we were given, let's say we were given x squared plus 6x plus 9. Okay, you need to find the binomial that was squared to get this. Okay, so if we break it down into uh, the form here, so let's say this is u, right? The x squared is our u, okay? And then this is our 2uv, okay? And then this is the v squared, and then this is the u squared. Okay, therefore our u is x, and then our v is 3, right? Because if you square 3 in 9, u is equal to x and v is equal to 3. So therefore, and then 2 uv, we check here, 2 our u is x and then our v is 3. So if we multiply that, we get 6x, which is exactly what this is. Okay. So then if you express it in terms of a square of a binomial, you can then get x plus 3 squared, right? Okay, so you can also write x plus 3 multiplied by x plus 3. Okay, so it's the same thing. Okay, those for this second form, we have u squared minus 2ub plus b squared equal to u minus v squared. Okay, so it's the same thing. It's just the minus sign is the difference. So let's give an example. Let's say we have the same pattern here. Minus 6x plus 9. So the difference here is this minus 6x. So our factors here are x minus 3 squared, right? So this can be written as x minus 3 times x minus 3. So if we perform this, that is x squared, and then this is negative 3x, and then this is negative 3x, and then this will be 9. Okay, which is equal to x squared minus 6x plus 9. Okay, which is exactly the given. Okay, now we have some 2 cubes. So if you can see this form, you can already know that this is its factors. Okay, so we've encountered this form also in the multiplication of polynomials. So let's have an example. Let's say we're given the factor x cubed plus 8. You can factor x cubed plus 8. So let's identify u. What is u here? U is equal to x, right? Because this is u cube, so this is x cube. And then what is our v? V is, what do you cube in order to get 8? So that is 2, right? So this is 2. So given that you already know v is equal to 2, given that you already know these two, your u and your v, then you can write, you can just substitute them in this form. Okay, so we have x plus 2 divided by u squared, that's x squared, minus uv. uv is 2x, right? And then plus v squared, which is equal to 4. Okay, so that is how to factor the sum of two cubes. Now what about the difference of two cubes? So this is the form of difference of two cubes. Difference of two cubes, okay? So once you've identified your u and your v, you can just follow this form. Okay, let's say we have the example x cubed minus 27. Okay, so what is our u here? The u here is x, right? Because this is u cubed. And then what is our v here? The v is, what do you cube in order to get 27? That is 3. Right? 3 cubed is 27. So our u is equal to x and our v is equal to 3. So following this form, we get u minus v, that's x minus 3. And u squared is x squared plus uv, that's 3x, plus v squared, that's 9. Okay, so this is the factor. These are the factors of this particular polynomial. Okay, so that's it for this lesson. So we'll proceed to factoring the second degree polynomial in the next one. So thank you.